Welcome to BBj Custom Objects Have class. Today we're going to talk about BBj Custom Objects, and for those of you who may never have used them before, we're going to spend some time on what BBj Custom Objects are and why you care. We're going to talk mainly though about what's new in BBj Custom Objects because there have been some significant changes in the implementation and the performance in the last few years. Lastly, we're going to talk about some changes in behavior that might not be exactly what you'd expect so that you're prepared for them. And then, of course, we'll summarize. What are BBj Custom Objects? Well, for those of you who have not used them before, BBj Custom Objects are BBj's class and interface objects. That means they use the class verb and the interface verb. They define a set of attributes and set of operations that all go together to make up one class. BBj classes help you write object-oriented code. So what is object-oriented code and why do you care? Well, object-oriented code, meaning based upon classes in this case, is easier to understand and maintain. It creates higher quality software products, and those products require a lot less rework when it's time to do enhancements or even just to fix simple bugs. The BBj Custom Objects improve software readability, clarity, and maintainability. Why do you care? Well, because you'll find that BBj code that uses BBj Custom Objects provides lower overall development costs, especially during the maintenance period. It can actually take a little more time to develop classes when you're not familiar with them and just getting started, but in the long run it won't. But also, in any case, it's the maintenance period and the ongoing work that is made so much easier by simplifying and focusing your code. It increases software development productivity. In the long run, you'll be able to create a lot more code a lot more quickly. And that code will be more able to be shared and reused from one program or application to another, and from one developer to another. The BBj Custom Objects also make handoffs and new developer training easier because they're easier to read and understand. If you want to find more about the benefits of plain old object-oriented paradigm itself, we do have an e-learning course that's up, available from the BASIS site, about software development. It was a training class in 2019 at our TechCon. But now, what are some of the things that are new in BBj Custom Objects? The most important thing, the thing we set out to resolve, was twofold: performance. But performance can mean two things: speed, and that's what we're going to look at here. When we implemented the new BBj Custom Object model, we made it more Java-like in version 2020. And in so doing, we got a number of improvements. The one you may care about the most is that runtime performance is better, and by that we mean the load and execution speed for equivalent code, meaning doing it in old classes versus doing it in the new classes. Performance testing results show that it varies slightly by operating system, of course, but it also varies by exactly what your classes and your code are doing in terms of how much you're going to save. The more complicated your classes and code, the more you will save. Looking at these two, you can see that roughly we got about a 25% performance increase or execution time decrease, however you want to think of it, when we did our testing. Now, if you want some of the more details, you can contact the BASIS QA department and they can provide you with more details about exactly what we tested and how we tested it, because it does vary by driver. The other thing that's likely important to you for performance is resource utilization, and by that we mean memory usage. In the same period of performance testing, using some tests, we discovered that we can decrease the percentage of the original memory that is used by about 60%, which is a not insignificant decrease. And again, for the details, you can contact QA. Besides the two goals we set out for, which was to make it faster and make it use less memory, we also got some other improvements from making our classes more Java-like. You can now extend Java classes with BBj Custom Object classes. So as you can see in the image on the right there, you can create a BBj class public named myRandom that extends a Java class that is java.util.random. Previously, this was not possible, but now it means you can use Java classes, but also then extend them and make them better, and better is your definition of better. We also now support reflection, Java's reflection, so that you can examine custom object classes. And reflection is a term that means basically that you can look back at the class from the outside and see what the class is at runtime, so that you can determine whether or not it has a particular method on it and whether or not it has a particular attribute and things like that. So reflection is the ability to wait until runtime and answer some questions about your class's composition. Here's an example of how it's done. It's relatively straightforward. You get the class object from your class, and then you ask it questions. And tell me about your constructor, tell me about your fields, tell me about your attributes, and you may iterate over them and act on them as you see fit. Another interesting change is that you can now define default method implementations on interfaces. Until this point, interfaces had to be completely empty of implementation details. All they could do was define the prototypes of the methods that would be part of the interface. However, with the newest addition here, you may now also, if you choose in your interface, define a prototype method and give it a default implementation, as you see in the red box there. And for an example of an interface method that doesn't have a default implementation, you can look right below the red box and see the method called doSomething, which has no implementation and thus needs to be defined by whatever class implements the interface. The class and the interface verbs both now support the protected access level, which restricts access to those classes and interfaces to only programs that are within the same directory on disk as the custom object class or interface declaration. So in other words, you have the ability to scope who can use your classes and your interfaces and restrict it by physical location on disk. Finally, all custom objects now come with a default toString method. So even if you don't define one, every custom object class has a toString and you can call it and see what it prints. Now so far we've been looking at new functionality. But there are also some improvements in error handling, and those improvements in error handling can impact in existing code. So let's look at how. What has changed in the behavior? Well, to be different here, during custom object field initialization, remember that a field is the piece of data that's in the custom class. During field initialization, you can now initialize the field to a value that is based on a different field. This was not possible until now. But remember that, of course, in order to base one field on another field, the first field is the one you want to already be defined. Otherwise, the second one cannot be set to use its value. If you tried to do that, it would be undefined. Here's an example of what we mean by initializing a field in a class to a value that is dependent upon another field. Notice that the name $ field is being initialized based upon the string that is present in the category bang field. As a side effect of that, uninitialized custom object fields are automatically set to null. So any field that isn't set by you to a particular value on the field initialization line is now automatically set to null. This is a safety feature, but if you haven't been relying upon that in the past, you may find it to be unexpected. So what's new in object error reporting? Well, better enforcement and reporting for errors. So if BBJ can't resolve custom object references, it cannot resolve them unless all of the types that are needed can also be resolved. This includes types for all classes that you extend, parent classes, interfaces that your class implements, field types within your class, and method arguments within methods of your class. Finally, even the method return values have to be known types in order for BBJ to resolve a reference to the type of the class itself. In previous implementations, our error checking was not enforcing all of these constraints, and so you may have some code that accidentally ran without those types being known, and it did the best it could to guess at what you were doing, and it may have been right or it may have been wrong. But nowadays it's being enforced. What else is new? If a class method is marked as static, which means that it's accessible at the class level and not at an instance level, then BBJ will now throw an error if the method's code calls any non-static object methods. Why? Well, non-static methods are only defined on instances of the class, and static code is only defined on no instance of the class. So you cannot cross the boundary, and correctly now we enforce that, which says static methods don't get to call non-static attributes or methods, fields or methods. And this is true even if you call the static method on a class instance where the invalid access theoretically could have been resolved. It is now handled the same way Java handles the problem. What else is new? BBJ will not permit you to define more than one method in any custom object class that has exactly the same values for all of these things. The method name, so if they have two methods with exactly the same name, and exactly the same number of arguments, and exactly the same types for all of those arguments, then that's called a collision. You notice overloading methods, where methods share the same name but differ by the number or types of arguments, is still supported. You just can't have two methods that have exactly the same argument set because the compiler won't be able to tell the difference at runtime. What else is new? Well, BBJ detects when a subclass attempts to overload a superclass method with one that has exactly the same signature, name, number of arguments, argument types, but has an incompatible return type. So in other words, when you override a parent's method, you must override it exactly as the parent implemented it. You may not change something. If you do, it's fine, but it's not an override. Note that a compatible return type happens to be the same type or a subtype of that type, or any type that BBJ can transparently cast to that type, which mostly applies to BBJ types like BBJ number and BBJ string. Custom objects are a great object for all uses. They increase your productivity and deliver a better project. So take every opportunity you can to benefit from the lessons that software developers around the world have learned. Object-oriented software development is a great step to better software. To be fair, the move to object-oriented software is not trivial, but you'll find that over time it is well worth the investment. Welcome to Test Away. Today we're going to be looking at something called BBj Unit Test, which is an Eclipse plugin that helps you to do unit testing with your BBJ code. To start us off, we're going to have a quick discussion, though, about exactly what unit testing is before we get into the implementation in the plugin. Then we'll talk about unit testing for BBJ using the plugin. Finally, we'll talk about some things that are new in the BBJ Unit Test plugin. And then we'll summarize. So what is unit testing? Those of you who are involved in quality, you know that there are various types of testing that can be done and should be done on software products. Unit testing is the type of testing or the process of verifying the correctness of code units at the unit level. That didn't help much because we already knew that from the name. So what exactly is a unit? Well, a code unit is the smallest piece of code that can be logically isolated in a system. In BBJ, a unit might refer to a function, a subroutine, or a class method or field. A class as a whole cannot really be verified by a single unit test because it's too large and too much is going on. To test an entire class, you require a suite of unit tests. Unit testing is designed to be done by the developer as part of their development process. It's not intended to be used by a quality control or quality assessment group. It can be used helpfully there, but its main purpose is to help developers do a better job of finding issues early in their code. So the theory for unit testing is that developers should test their own code early and often. And in order for that to happen, we have to make it easy. And that's what the plugin is here to do for you today. So remember, a unit test verifies the smallest piece of code that can be logically isolated in a system. The term isolated here is important. Tests that interact with other systems, that access a database, that communicate over a network, that touch a file system, that require system configuration or that have to run at the same time as another test are system tests, not unit tests. Unit tests are small, bite-sized chunks. Now, unit tests could do a lot of things, but the framework of unit testing is really designed to do only a few simple things, and that's what helps it be efficient, effective, and useful to a developer. So here are some benefits of unit testing. It reduces development cost. Why? Well, it helps the developer to find defects in both new and changed code. It helps them to find defects earlier in the development cycle. It also decreases the workload on the quality team because the developer is finding his own product problems first. And it increases the quality of the final product because more people are testing sooner and longer and more effectively. It encourages developers to analyze how their work products will actually be used. They have to think like a user when they go to write a unit test. And by that we mean a user of the unit, not necessarily an end user of a user interface. So if you're testing perhaps a particular method with a unit test, then the user would be whoever in the code is going to call that method. Remember the small chunks. Here's some more benefits of unit testing. It improves productivity. It makes your developers have to do testing as a natural part of their daily work. It helps them find defects while you're still working in the same area of the code. This minimizing the shifting of the mental gears and having to stop and say, oh, what was I thinking when I wrote this 2 days ago? The answer is I just wrote it and I just tested it. It permits a large number of tests to be run quickly with little human cost, and permits a large number of tests to be run over and over and over again. Thus, the test results are comparable, meaning if I run the same test 3 times in a row over 3 days, I can reasonably expect to get the same results unless there's something has changed and there's a problem, which is what I'm out to find. It provides better documentation of the design. Why is that? Well, clear tests are a form of internal documentation of the intended behavior. What was the developer intending for this particular piece of code, this method or subroutine or function or attribute to do? Hopefully that is captured in the design and the notes and comments in the test. Now, if you know much about unit testing, and you may not, but you may already guess that unit testing is language specific, meaning the way you would test a piece of C++ code and test a piece of Perl code and test a piece of BBJ code are different because the code syntax, semantics, and structure can be quite varied. So in unit testing for BBJ, each test is written to verify a specific unit using a specific language, in our case BBJ. There are other frameworks such as JUnit, written to do unit testing in Java. There's CPP Unit, that's written to do unit testing in C++. There's C# Unit Test for C#. And of course, there's BBJ Unit Test for BBJ. So how do you actually make it happen? Well, you write and run BBJ Unit Tests by using the Eclipse BBJ Unit Test plugin. That's what we're here to talk about today. The tests that you're going to write are written in the BBJ language. They run in the BBJ language. And the results are usually displayed in Eclipse so that you can see them right there where you're editing your code. That's what makes it efficient and effective. So how do you get started? Well, to get started, you follow these steps, and these are basic steps that we'll just fly over really quickly, but you set up a development computer that has Java, BBJ, Eclipse, BDT, and the BBJ Utilities plugin suite, because that's where you're going to find the BBJ Unit Test plugin. And for those of you who haven't done that already, the explanation is at our Eclipse plug-ins page off of our Basis website, which explains how this happens. We're not going to spend any time on it today because that's a whole story in and of itself, but we're going to assume you've already got a development environment set up and you're ready to write a BBJ unit test program in Eclipse. Then you run the BBJ unit test program in Eclipse and you view the results there. So the new thing is that you also now can schedule the execution of a unit test outside of Eclipse and have the results written to an XML file. So basically you can automate your unit test execution. That's the part that might be really helpful to your quality group. So let's look at how we actually write and run unit tests for BBJ. If you want detailed instructions on writing BBJ unit tests, all you have to do is go to our online help system, our web help system, and search for unit test. Which, as you can see in that screen there, when I searched for unit test, I found the top 2 returned values are one about command line BBJ unit test and one about the Eclipse plugin. So the one about the BBJ Unit Test Eclipse plugin there is where you will go to get started. It gives you expanded details about how to actually ensure that your development environment is correct and to help you get up and running. We'll talk about the command line one later. So what does a BBJ Unit Test class look like? Well, it's a class that holds unit tests, logically. And here's a default BBJ Unit Test file created for you by Eclipse. And when you ask Eclipse and BDT and BBJ Utils to create a unit test file for you, it does so, and it populates it with a default class. In this case, we named it MyUnitTest, and it comes up with a couple of default empty methods that are already in place for you, sort of like stubs, so that you can get up and running pretty quickly. To make it a unit test class, all it really is a custom object class that has a series of annotations. And the annotations are those things that start with the @ sign. You'll see a couple of them in the image there, the @before class, the @test, and the @after class. And we'll talk about what those mean in a few moments. And those are comments, and those comments immediately precede the methods that they are describing. Those help the BBJ Unit Test plugin to identify those special methods so it can act on your behalf. And let's see just how that happens. It uses annotations to identify unit test methods, and by that we mean a test case. So when we talk about a unit test method, we mean a method on a class, and that method has an @test annotation, and it represents what we would call one unit test case. And that means that that's one piece of code that can return to be viewed by the user 2 options, either success or failure. That's what a test case does. The annotations also help us by defining categories and suites, or grouping tests and classes together so that you can manipulate them at a higher level instead of one method at a time. It allows you to control the test execution order, which things you wish to execute first, which runs you wish to execute second, and so on. The most commonly used annotation is the one we saw in that first picture, the @test. And the @test annotation precedes immediately the prototype for any method that follows a certain set of guidelines for its prototype. In this case, you see as an example there the test method. And only methods that are preceded by the @test annotation are unit test cases, and only those unit test cases can report success or failure. But secondarily, there are other annotations that you can be interested in, such as the @before. The @before marks a setup method that is run immediately before each @test method is executed. So if you need to have some setup before you start your test that is consistent and you don't want to write it over and over and over again, you define it in an @before, and it's run before every test. Logically, there's also a before class, which means it's run once before the entire class's test cases are run, and only once. Whereas the @before is run before every method, the @before class is run once at the beginning. There's also correspondingly the @after and the @after class, which has logically what you'd expect. The @after is a cleanup method run immediately after each test case, and the @after class is run once at the end before exiting all the tests so that you can do any big system cleanup that you might need to do only once. So to make it a unit test, the method has to be a public method of a public BBJ custom class. It has to be defined in a BBJ source file that has a .bbjt file extension, and Eclipse will do this for you automatically. If you tell it to create a BBJ unit test file, it will do that. The method also has to be marked with the @test annotation, as you see there. And the method can take no arguments. Notice there's nothing between the opening and closing curved brackets. And it can return nothing. So the return type is void, meaning you cannot return anything. So the only way to communicate the success or failure is by using a model that we'll talk about in a moment called the assert methods. And we're going to do that in just a minute. We'll talk about how you report success or failure. At-test methods assert the truth of one or more logic statements by calling methods on the assert class. So the assert class is a special class that the plugin provides for you and lets you then say certain things that are consistent with the Java unit test model for assert. So if you're familiar with Java's unit testing, this is similar. If an assertion logic statement is false, then that assertion fails and reports failure to the plugin. If an assertion's logic statement is true, then that assertion succeeds and it reports success to the BBj Unit Test plugin. Each test method reports success or failure based on the result of all of the assertions that it makes. If any assert in the method fails, then that method reports failure. But if every assert in the method succeeds, then it reports success. So it only takes one error to report failure, but it takes all successes to report success. The assert class offers a number of logical assertion methods that you can use. Remember, for more details, you can go back to the document that we mentioned earlier and find out. But for the moment, here are a few examples of some of the more common ones. There's a method called equals, and you call it with two numbers, and it returns success if the two numbers are indeed equal and failure if the two numbers are not equal. There's not equals, in case you want to go the other way and report that it succeeds if they're not equal. Note there are variants for other argument types like strings and such. I'm only covering one or two of them here. We don't have time to cover them all, but you'll find a whole list, including things like is null. So if you want to check if something is null, and is not null. If you want to check that a variable is not null. There's also a special one called the expect, which means you expect an exception to be thrown, and what you're verifying is that the exception you expect is actually thrown. And by that you mean specifically a particular numbered exception is thrown when it runs. Note, assert methods are only used inside the at-test unit test methods. They don't mean anything and they're not used anywhere else. So here are a couple examples calling assert class methods. You can call assert equals with two values. You can call not equals with a value of your choice and then a comparison value and so on. Remember that assert class methods are all static, so you call them using the assert dot notation as shown above, where the assert is the name of the class. So you're calling static methods. Once you execute, you get a really nice little view at the bottom of Eclipse that will show you the results of your run. And we don't have time to go over this today, but I'll point you in a moment to a documentation that explains it in detail. But as you can see, that bright red thing on the right tells you that not everything went well. And in fact, if you look to the left, you see that there was an assertion error, 1, and an execution error, 1. And if you look farther to the left over there on where it says tested, you'll see we ran 3 tests. And if I go to the table at the bottom, certainly there are the 3 tests that we ran, and one of them is an assertion error and one's an execution error. So there's more information coming about that, but for today, just be aware it's a nice user-friendly view. So the latest enhancement, though, says that you may not want to run the BBj Unit Test plugin. You may instead just want to run your unit tests programmatically. Maybe you want to schedule them at night or something, but not use Eclipse. And you could schedule them for later, kick them off and go home, and then examine the XML output file the next day. You could integrate execution and analysis into an automated build system where nobody's there at all, and then the build system can parse the result and notify the appropriate people. And finally, here's an example of the sysconsole output when you run from the command line. Notice that if you happen to be sitting there, you can watch the sysconsole output, and it tells you where did the results go in that red box at the bottom. Where is the XML file? And if you look inside that XML file, you'll find the standard XML kind of organization of elements that tells you, did I run each test, yes or no, and did it pass or did it fail, and if it failed, what went wrong? It's pretty much the same information you'd get graphically if you were sitting there as a user. But for detailed instructions on running this, all you have to do is go back to the help system, and remember, type unit test. And there you go. That top link is the one about the command line BBj unit test, and it will tell you all about the command line unit test. So those two documents you see on the screen there are your primary resources for everything you ever wanted to know about BBj Unit Tests. Not only can you write unit tests and run them in Eclipse, but now you can automate that to run whenever you want them to. There's no reason not to test your code. Your users will appreciate it as much as you do.
Hello, my name is Brandon, and I'm a software engineer for Basis International. Today I'm going to be going over the BBj code formatter and showing off a couple of new enhancements we made that we hope to be beneficial for our users. For a general overview of what we will be covering, we'll go over what the BBj code formatter is, what new features and enhancements have been added, why you should actually care about the BBj code formatter and use it, and a brief wrap-up of everything we talked about in this presentation. What is the BBj code formatter? Basically, the BBj code formatter plugin gives you an easy way to format and clean up your BBj code with the simple press of a button. It's tied in directly with Eclipse and becomes easily accessible when you download and install the BBj utilities. It allows you to select the BBj source file that's open in the editor and quickly format it to a specified standard. The output that's generated can be customized and fine-tuned through the user preferences. There are a couple of different types of formatting that the BBj code formatter can do. It can remove line numbers, which is required by the BBj code formatter when trying to use any other type of formatting in the user preferences. It can remove line continuations and apply a standardized indentation for readability. If you want to convert single-line if statements to multi-line if statements, it can go through and convert all of these over. If you have multiple statements on one line and want to make the code a little easier to follow, the BBj code formatter will go through and move the statements to multiple lines if it notices that the statements are separated by a semicolon. The code formatter can also go through and convert all of the business basic keywords to uppercase. So, how do you use the BBj code formatter? To start off, open a BBj program in a BBj editor. Click the Format Toolbar button, which is located directly above the open source file with the rest of the BBj utilities. After a brief moment, you'll notice the code that's open in the editor will be formatted. You can either save the file if you like the changes that were made, or revert back to the original file. To see some more of the BBj code formatter in action, here are a couple other examples of formatted code. If you have a single line if statement, it can go through and move it to multiple lines. Before, the code was condensed on one line, but after formatting, the code has been moved to multiple lines and is much easier to follow and understand at a glance. In the original code, the developer was making use of line continuations. After formatting, all of the code that involved the line continuations has been moved to a single line that's easy to follow. Here is a BBj program that is still using line numbers. Notice that the program also includes a couple go-to statements pointing to the line numbers. Now you might remember that a denum is required when using the BBj code formatter, but might be skeptical that it will affect your code, especially if you're also using statements that go to a specific line number. But after performing the denum, you'll notice that the code has remained intact while the line numbers have been removed. Any statement that involved going to a specific line number has been replaced with a label, and the code works exactly as it did before. You also won't have to deal with renumbering your files now if you need to add a couple lines of code before the label. Now for the new features and enhancements that have been added to the BBj code formatter. In the past, the BBj code formatter has been limited to the amount of customizability that the user has had when formatting BBj source code. Other than a few user settings found in the preferences, the BBj code formatter has largely been you get what you get when formatting. This doesn't necessarily work for everyone's workflow, and we've noticed, which is why we're trying to give the user greater control over their formatted code. As a step in the right direction, we've added the ability to go through and collapse multiple blank lines into one, remove all trailing whitespace at the end of each line, and change all end-of-line characters to a specific type that is set in the user preferences. Let's look closer at each of those features. For collapsing blank lines, if enabled, the BBj code formatter will go through and find any instance of back-to-back blank lines and collapse them into one. Previous versions of the code formatter removed all blank lines and condensed the code, unless it came across a special statement such as an if or on close, But now blank lines that were inserted by the user will now remain intact to help improve code legibility. Only timelines will be removed now is if the collapse blank lines is enabled. Best part is that all of the previous code formatting features remain intact and don't have an effect on the blank lines. For a quick preview, the following code has multiple instances where there are multiple blank lines mixed in with single blank lines and no blank lines. Running the BBj code formatter with collapsed multiple blank lines enabled will result in the following output. As you can see, all instances where there are multiple blank lines have been condensed into a single blank line, while the rest of the code remains untouched. Special statements, such as the onClose statement at the bottom, retain their previous formatting rules. For removing trailing whitespace, it's pretty straightforward. If enabled in the settings, the BBj code formatter will go through and check the end of each line for any whitespace. If the line contains any whitespace, it will be removed. In this little snippet of code, both the API and sysGUI lines contain a little bit of trailing whitespace at the end. If we run the BBj code formatter with remove trailing whitespace enabled, all of the whitespace will be removed and the lines now end with the last character. Both of these new settings can be found at the bottom of the code formatting section under the BBj code formatter user preferences, where they can be both enabled and disabled easily. The final feature we're going to go over is changing the end of line characters. Depending upon the desired outcome, or the type of system the code is being run on, there may be times you need a quick and easy way of changing the end of line characters. The BBj code formatter allows you to go through and replace all end-of-line characters with one of the three options. Option 1 is probably the most common, which is the line feed character, or, as you might know, \n. The second option to choose from is the carriage return, or \r. The final option for Windows users is a combination of both the line feed and carriage return character, which is the double \r/n. Once one of the options are selected, the BBj code formatter will go through and find any end-of-line characters and replace them. Let's take a look at an example. The message line contains three end-of-line characters. There's a \n, a \r, and a combination \r/n. Let's see what happens when we enable end-of-line character replacement. If we choose the line feed character and run the BBj code formatter, you will notice that all of the end-of-line characters have been replaced with \n, and the rest of the code of the line has remained unchanged. Same thing happens if we change from the line feed to the carriage return character. All of the end-of-line characters are replaced with a \r. And last but not least, all the characters are replaced with the double character \r/n. The characters can easily be swapped back and forth without any issue depending upon which one is needed at the time. This new setting can be found under the code replacement section in the BBj code formatter user preferences. It's set to ignore by default. So why should you care about formatting your code? Well, formatted code has many benefits over unformatted code. The most noticeable improvement you'll likely come across is readability. Formatted code is much more legible over its unformatted counterpart. Since the line numbers are removed when formatting, you also don't have to deal with the go-to statements involving line numbers when trying to follow along in the code. This makes the code much easier to follow. The code formatter also greatly improves readability by using matching indentation. All lines of code that are in the same block will have the same indentation. This helps immensely when trying to follow through the code and see what's executed and what isn't. Going off readability, formatted code can also greatly improve efficiency. Having code that's easier to read also makes it easier to follow along. This means less time trying to figure out what's going on and more time trying to fix any issues or bugs. This especially speeds up the learning process for new developers trying to understand the code base. Formatted code can also lead to a reduced number of bugs in the code. The human mind can do amazing things, but sometimes it might get stretched a little thin. It can be hard to keep track of all the variables and other things going on in your program, and you can easily lose track. Formatting your code helps with following along and knowing where you're at in your program and what still needs to be done. It also completely removes the stress of having to follow styling rules while you're coding, so you can just focus on what you're writing. Another area that formatted code has added benefits in is in consistency. Everyone using the same coding style helps standardize the code across developers and teams. Once all the settings are the same, everyone can format their code with the push of a button, and the code format will be the same as the developer sitting right next to you. There also isn't a learning curve for new developers. They push the same button, and their code is in the same format as the rest of the team. Another area where consistency will be improved is when using diffs. Since the line numbers are removed, only actual differences in the code will show up when performing a diff. New line numbers or any sort of thing in that nature won't appear as a difference anymore. This makes it much easier to read through the diffs and actually see what's changed, which helps when you're trying to consistently keep track of files. So to wrap everything up, developers can expect to see great improvements in efficiency and readability when using the BBj code formatter. These new features are intended to complement the existing formatting options and are the first steps towards giving users more control and flexibility over their formatted code. We plan on expanding the amount of options users have when formatting their code in future BBj releases.
Let's move on to a different area now having to do with BDT. We're going to cover one or two of the most valuable of our BDT tips. These can all help you to be more productive and should let you experience a little more of the power and flexibility of the Eclipse plugin, as well as a little more comfort and convenience in working with BBj code. Let's look at using clipboard history. Do you ever need to copy and paste multiple blocks of text or images? Are you tired of only being able to put one item in the copy-paste buffer at a time? If so, then you need a clipboard manager. There is an Eclipse plugin called PDE Tools that's available from the Eclipse Marketplace. It provides clipboard manager functionality in Eclipse itself and works on Mac and Linux computers. And many Linux operating systems also support optional clipboard managers you can install, including a couple like Parcelite and CopyQ. However, all those require some configuration work and installation on your part. And for the moment, we're going to take a demo look here at an easy way to do that. Since Windows 10 users have a built-in clipboard manager, it's part of the Windows 10 operating system, and that clipboard manager is accessible and works in Eclipse editors, we're going to go ahead and talk about that one for today. Just makes our demo easier. For more details about using clipboard history in BDT and Eclipse, including details about Linux or Mac environments, you can see the BDT tip document, tip number 7, that's available from our IDE user group Wiki's Dev Tips page. So how does clipboard history work? Well, let's find out by first looking at how to enable Windows's clipboard history, because by default it is not enabled on Windows 10. So click the Windows Start button in the lower left corner of your desktop. Note this is not the same as the Windows button on your keyboard, even though the icon image of a 4-segmented window looks exactly the same. We're referring in this case to the Start button in the lower left corner. You click that. Once you do that, you get the option to select Settings, System, Clipboard, as you can see on the right-hand side of the screen there, and access the clipboard settings. You'll see there's a red box around the clipboard history settings, and that is where you go and turn on the clipboard history switch. You can read the details there if you wish, but that enables the Windows Clipboard Manager and gives you clipboard history. Now, once clipboard history is enabled, you can use it, and it is functioning anytime you issue a copy command, and the most common of which is Control+C in a lot of Windows applications, but there are other ways like Control-Insert that you can access clipboard history. And every time you do that and issue a copy command, that selection is added to a history list that is maintained at the operating system level. At any time when your edit cursor is in an open Eclipse editor, such as a BBj code editor, you can then hit the special key command, which is the Windows logo key, not the Start button. Now we're to the other button, the one actually on your keyboard. Hit the Windows logo key And while holding it down, hit the V, and you can view your clipboard history. The image on the right shows what you'll see once you do that. Notice it pops up a small overlay that says clipboard at the top, and notice that in this case, in my view, there are 4 entries in that clipboard history, and one of them happens to be highlighted at the very top. That's the most recent one. You can also scroll down to see more entries. If there are more than will fit on that screen, there will be a scroll bar on the right. You can scroll back to the level of your storage. Click on any entry to paste it directly into the editor where the input cursor sits. What are some limitations and details of this particular tip? Since the operating system stores the clipboard entries for us, they're available even after you exit an application. So that's the good news. I can copy from a notepad execution and close the notepad and then go over to Word and paste into Word. They're available cross-application. They're also available anytime you like, as long as the application supports the clipboard use. It supports cutting and pasting. They are usually cleared when you restart your computer, though. Why? Because the operating system maintains them, and as far as they're concerned, you've wiped the slate clean when you shut the computer down and start over again. The clipboard history list can include entries that cannot be pasted into any open editor. That includes images or binary files or anything like that. So if you make a request to paste an incompatible entry, such as you have in your clipboard history a PNG image file and your cursor sits in a BBJ source code text file, and you attempt to paste, what will happen in general, such requests are silently ignored. So it will not happen because there's no way to put a picture into a ASCII text file. Let's look at another thing you can do that's really handy in the IDE. It's called toggling rem comments. So how often do you need to temporarily skip a block of code in one of your programs? No telling how long, but for a while you're going to want to skip a block of code. At some later time, though, you think you may once again want to execute that code block. Well, the standard solution is to comment the entire block, causing BBJ to skip it during execution. When you're done, uncomment the whole block. That sounds simple enough, so what is the problem? The problem is that BBJ only offers single-line comments, so to comment each line of a block, you would have to add a rem marker at the beginning of each and every line. To uncomment that block, you would then have to go and remove the rem marker from that same set of lines, one at a time. With large blocks of code, this could be really painful. The BDT solution is to support commenting and uncommenting an entire block of code with a single command. We call this toggling comments, and let's see it in action. By the way, for more details about toggling comments in BDT and Eclipse together, you can see the tip document, BDT tip number 10, that's available from the IDE User Group Wiki's Dev Tips page. How exactly does toggling work? Well, first you have to have a BBJ code editor that is open, showing any BBJ source file. As you can see on the right there, we have testgrid checkbox.bbj, and you select multiple lines of code, and the blue background indicates that lines 12 to 23 are currently selected. You press the key combination, which would be Control plus / on the Windows keyboard or Unix, and then it's the Command / on Macs. And each of those selected lines now starts with rem space. As you can see in the after box on the right-hand side there, each of those blue lines now starts with rem and is officially a comment. When you are done skipping that block, all you have to do is toggle the comments off again. And how easy is that? You select the block of code, if the lines are not already selected. You press the same key commands, Control / or Command /, and each selected commented line is now uncommented and no longer starts with rem. Limitations and details about this tip A line is selected if any portion of it is selected. So if you don't precisely want to start at the beginning of a line and go to the end of the 25th line, you can just grab any portion of each of those first and last lines, and that will include them in your block to be commented or uncommented. If no selection exists in the active BBJ editor, but the input cursor is present in the active editor, then the toggling will apply to the line in the editor that has the input edit cursor. In other words, it's a quick way to rem comment one line where your cursor is. BBX comment lines begin with a rem marker, which can only be preceded by white space or a line number. So when you go to uncomment, if you have lines that start with something other than that, such as a label followed by a rem marker or anything like that, the toggling does not work. It is limited to the lines that start with rem when they're selected. Also, if your BBX code has line numbers, then BDT will insert and remove the rem markers following the line numbers. Remember, BDT's comment toggling uses only rem all capital letter markers. So for some reason you want to have mixed case rems, they won't be uncommented when you go to untoggle them. And all of the ones that it inserts for you will be capitalized.